Okay, this is problem number 3 on section 2 of chapter 8. You need to read the problem and identify the claim, the null hypothesis, and the alternative hypothesis. So pause the video and do that. Okay, so here in this problem they say use a 10% significance level or 0.10, that is alpha, to test the claim that the rate of inaccurate orders is equal to 10%. So the proportion, so the claim is that the proportion of inaccurate orders is equal to 10%. So let me write this. This is the claim. If you translate this wording into a mathematical statement, and that goes on the alternative, on the null hypothesis. The null hypothesis only takes equality as a mathematical statement, and the alternative hypothesis will be P is different than 0.10. Whenever the claim is on the null hypothesis, the alternative hypothesis will be different. Okay, is the opposite of the null hypothesis. Okay, so whenever the claim here is on the null, the alternative takes the symbol of different. Okay, now in the p hat is the proportion of inaccurate orders in the sample. So the sample we obtain here, it says we have 40 orders that were not accurate out of 337 orders. This is our p hat. And the test statistic, well, in this case, on this section 8.2, we are testing a population proportion. We are using this formula. Okay, so let's go step by step. Z is equals to a p hat, which is 40 over 337, minus that p is really the one that is on the null hypothesis, is this one right here. It's going to be 0.10. All this divided by the square root of, again, that p and q is the one that is on the null hypothesis. P is 0.10, that is the assumed value, and q is the complement of p. So by complement I mean you take it away from 1, so that will be 0.90. Okay, so you have 0.10 times 0.90, all this divided by the sample size. The sample size is 337. Okay, so that's how you find the test statistic by hand. I'll show you how to get all this done with a shortcut on the calculator, but okay, let's do that first here. And let's perform the numerator, which is 40 over 337 minus 0.10, enter. So all that will be divided by, let me open the parentheses, the square root, a per second, x squared here, of 0.10 times 0.20, 0.90 divided by 337. Now I get out of the parentheses and I press enter. So that is the test statistic, the one I have here. Okay, so if you round it up to the second decimal place, this is what we have. Okay, the next part, it says identify the p-value for the hypothesis test. Well, this type of test corresponds to a double tail test because the alternative hypothesis has the symbol of different. So you have this tail on the left, this tail on the right, and the test statistic that we obtain right here. Let me write like a little T on the bottom, so just to in the subscript to identify that there is a test statistic. It is 1.14. On this side will be negative 1.14. Okay, so the p-value is the sum of these areas right here. That's the p-value. So in this particular case, the p-value is the probability of obtaining a score less than negative 1.14 plus the probability of getting a z-score of greater, so let me edit that part, greater than 1.14. Okay, that will be the sum of these two areas. So to find that area, we go to the calculator and choose a normal CDF. So we go to second, parse, normal CDF is number 2. Let me calculate this area, and I'm going to choose a very extreme low value on the left side of the number line. You might leave it like that if you want. Let me just leave it like that for this case. Okay, I'll leave it like that. And type my upper limit will be negative 1.14. Okay, this number is a very low value. I mean, very extreme low value. This number is the upper bound right here, and we keep the mean and the standard deviation the same, and we get that number. Okay, keep in mind that this area is only the area on the left, and since the distribution is symmetrical, this area will be the same area as this area. So you might just multiply that by 2. We only multiply by 2 when you have a double tail test, and we have the p-value right here. So I know this is a long process. There is a shortcut on the calculator just by pressing start and going to test, and make sure you select one prop z test number 5, and you need to input all the information here, the value of the null hypothesis, the one that is assumed, which is 0.10. That's the one on the null hypothesis. The proportion of orders in this particular case that were inaccurate, which is 40. The sample size is 337, and the symbol, the mathematical symbol on the alternative hypothesis, which is different here. And we might hit calculate, or we might highlight draw. I like this. In my particular opinion, this is it's actually better to visualize it. So I press enter, and this is what I have. This is the test statistic, and this is the p-value. So those are the numbers we obtain by hand. Okay. So the next part of this problem is writing the conclusion. Okay. So again, let me see. The null hypothesis was that p is equal than 0.10, and the alternative hypothesis P is different than 0.10, the p-value is you see here the p-value was 0.253, and alpha is which is the significance level, is 0.10. Okay, alpha is 0.10. So I would use the p-value method to decide if I reject or fail to reject. If you read the book, you watch the lecture videos, they explain that we have in general two ways to do these problems, using the p-value method or the critical value method. So since in this case the p-value is greater than alpha, so this value 0.253 is greater than 0.10, we fail to reject the null hypothesis. And the claim, if you read the problem, the claim is on the equality, on the null hypothesis. So the claim is here. So the original claim includes equality, and you fail to reject is this part right here. Okay, original claim includes equality is right here, and you fail to reject. This is the way you word the conclusion. There is not sufficient evidence to warrant rejection of the claim that, well, what is the claim? Well, the claim is that the population proportion is 0.10. Okay, so, or 10%. You see that is the correct answer. Fail to reject, and there is no sufficient evidence to warrant rejection of the claim that the rate of inaccurate orders is equal to 10%. So that's how you do this problem. I did show you the long way with formulas, okay, with all these formulas, and the short way, which is with the calculator.